So what this is called is the symmetric difference quotient. And now let's break this down to see what it represents. So this point, a plus h, is a and then a point a little bit to the right of h. And then a minus h is a little bit to the left. So this is if we want to approach h. So this is if we want to approach the a value from both sides equally. So now we're going to use this symmetric difference quotient with this function. So the reason we're using h equals 0.01 is we want a number that is really close to 0. And the reason we can't just plug in 0 is on the calculator, it can't evaluate it at 0 like we do with limits. It has to work with a number really close to 0. So using the symmetric difference quotient, we get that f prime of x is equal to f of a plus h minus f of a minus h, all divided by 2h. So let's first break this into the components. We have that f of a plus h is equal to 4 times a plus h minus a plus h squared. And we have f of a minus h, which is 4 times a minus h minus a minus h squared. And since we're looking at x equals 0, this is our a value, and we have our h value. So now all we have to do is plug everything in. So f prime of x is equal to 4, 0 plus 0.01 minus 0 plus 0.01 squared minus 4 times 0 minus 0.01 minus 0 minus 0.01 squared, all divided by 2 times 0.01. And now at this point, we are going to calculate this on our calculator. So to do this on our calculator, we're going to use our fraction tool. So it's alpha f1, and now we have our fraction. And we do this so we get all of our parentheses right. Then doing this on our calculator, we end up getting 4. So this whole thing is equal to 4. So this means that the derivative at x equals 0 is equal to 4. Now let's look at this example again, but we're going to use our calculators to solve this. So we have f of x is equal to 4x minus x squared. And what we did here is we found the derivative when x equals 0. And now I'm going to use a function called nth derivative. So math 8, and it sets up the derivative for me. So I'm taking the derivative with respect to x, and my function is 4x minus x squared. And I want the derivative when x equals 0. And there you go. It did all of that algebra for me. So now we're going to move on to example 2. And it's going to say compute f prime of x at x equals 2 if f of x equals x cubed. And in later videos, we'll learn how to do this by hand. But for now, I'm going to teach you how to do it on the calculator. So it's math 8. And then the calculator is going to spit this out. And now all we have to do is fill in the blanks. So this is d dx, x cubed, and x equals 2. So math 8 d dx, x cubed, and x equals 2. And I go ahead and hit enter. And it's going to give me 12.000001. And the reason it does this is because it's trying to compute it on its own using this difference quotient. So we know that this is equal to 12.00001, which is approximately just 12, which is what the actual derivative is at the point. So we get f prime of 2 is equal to 12. So now on your own, I want you to use the calculator to determine f prime of 0. All right, let's give it a try. So on the calculator, I did it already, but I'm going to do it again. It's math 8 d dx 4x minus x squared, x equals 0, and you get 4. And this is how you set it up in your calculator.